So in this video, we're going to go through the notes for 4.2. So it's all about applying congruence and using triangle information. So vocab is at the beginning. So if you say that two figures are congruent, that means that all the parts of one figure are congruent or equal to the parts of another figure. So those two figures that you're talking about will have the same size and the same shape. Okay, that's the whole idea about congruent figures. They are exactly the same. So if you put one of those figures on top of the other figure, you would not be able to tell that you have two figures stacked because they are identical. Okay, here's our theorem. Third angle theorem is if two angles of one triangle are congruent or equal to two angles of another triangle, then the third angles are also congruent or equal. And that's based on the premise that you have 180 degrees in both triangles. And you will always have 180 degrees in your triangles. Therefore, if you know two of the angles, you can figure out the third. But if you know that two of the angles in one triangle are the same as two of the angles in the other triangle, then you would know the third angle of each. It would be the same, and all the angles are therefore equal. Okay, let me slide down a little bit. Okay, so here's some properties. Now, we're not going to really use a lot of these, but I just want to have you understand them, and when they show up, I'll explain them to you. So the reflex property just says self equals self. Okay, we use this more in proofs, but it helps us explain why shapes are congruent when they share a common side. So it's just self equals self. So triangle ABC is congruent to triangle ABC. Makes sense? Because they are one and the same. The symmetric property of congruent triangles just means read it backwards. If triangle ABC is congruent to triangle DEF, then read it backwards. Then triangle DEF has to be congruent to triangle ABC. Okay, so think of it just with letters. If A is congruent to B, then B is congruent to A. The transitive property relates three things. So if triangle ABC is congruent to triangle DEF, okay, and then this same DEF is congruent to JKL, then what you can say is that ABC is going to be also congruent to JKL. So think of it this way. If 1 equals 2 and 2 equals 3, then 1 is also going to equal 3. But think of it in letters. If A equals B and B equals C, then A will equal C. Okay, so think about that. When it shows up in our work, I will point it out. Okay, so this is probably the most important part of this exercise. So this is critical. You need to identify congruent parts in these triangles. And these triangles, you can see, are very marked up. So what they've done is they've put all this information on the triangle. And so what I want you to do is, if you are given this kind of information, that you also make similar markings on your triangle so that you can really see what's going on. So it says identify all pairs of congruent and corresponding parts. So that means look at this and tell me what you have. So the first thing that you want to do is get a statement together. This is a congruency statement. So it's based on this order is critical, because it's based on the angles. So look where J is. J has 3 little hash marks. So does T. That's why J and T are both in the first place in their respective triangles. Look at K. K has 1 hash mark, and so does S. That's why K and S are in the same place. And then L has 2 hash marks, and so does R. And that's why L and R are in the same position. Okay, so when I read my congruency statement, what I know is that if this is true, then J has to equal T, and K has to equal S, and L has to equal R. And that does indeed happen. All right, each of those angles are indeed equal or congruent, and I can tell that fact by looking at the markings. Okay, let's talk about our sides. Our sides are also marked. Single hash mark, single hash mark. Double hash mark, double hash mark. Triple hash mark, triple hash mark. So let's see which are congruent. So notice that we're using angle symbols when we talk about angles. We're going to put a line segment symbol on top when we discuss line segments. A triangle is made up of 3 line segments. So JK, single hash mark, is congruent to TS, also single hash mark. I can do that by looking at the statement. The first 2 letters are JK, and the first 2 letters for the second triangle are TS. That's how you can get the statement. Let's continue using our congruent statement. So the second 2 letters are K and L. So K and L must equal S and R. So that's what I write. KL is congruent to SR, and they're segments, so I have segment notation. KL and SR both have double hash marks. The last ones, grab your first letter and your last letter. First letter, last letter. That would be LJ. First letter, last letter. That would be RT or TR. So let's look at our diagram, make sure that we're all consistent. So JL or LJ, remember it doesn't matter how you write that, is going to be congruent to RT because they both have 3 hash marks. So you can use your congruency statement, or you can use your diagram if one is provided. If there's no diagram provided, you are able to get the same information about corresponding angles and corresponding sides from a congruency statement. Okay, so then I did one here, which I'll let you look at, and you can see that I've marked up my triangles. I have a congruency statement, and then I have all my angles and all my sides. So you should maybe sketch this yourself and see if you can come up with the same thing. Okay, so example 2 hits home the fact that these properties of congruence extend beyond triangles to other shapes as well. So here are quadrilaterals. And I've done all this marking. It gets kind of cumbersome, and that's why it really is easier to use the diagram sometimes. So find the value of x and y. They didn't ask me to list the congruencies, but they asked me to find the value of x and y. So what I did was I went around my shape, and I tried to figure out what I had to get these values of x and y. And I found 2 equations. So I saw that I had a value over here for GF, and GF are the last 2 letters. I then looked at QR, and sure enough, I have an expression. So I set 12 equal to 2x minus 4. So that's one equation I figured out. Then I saw I had a y in here and a y and an x, and that was angle Q. So angle Q has to equal angle F. Angle F is 68 degrees. So here's my second equation. So 68 equals 6y plus x. So I need to find a definition for y and one for x. If you have 2 variables in one equation, you cannot solve for 2 variables. All right? You can solve if you have 1 variable in one equation. So I focused my attention down here, and I said 12 equals 2x minus 4, I added 4 to both sides, getting 16. I divided by 2, getting x is 8. The fact that I was able to isolate my x allows me now to use this x in place of the x up here. So 8 is going to be replacing the x. I'm going to subtract 8 from both sides, divide by 6, and I'm going to get y equals 10. And that is going to be the other value I needed. So I use my congruency statement understanding to figure out what values I can set equal in order to solve for both x and y in this problem. Okay, so this example shows a little something about how we can take work from a previous section and apply it here. So, angle 1 and angle 4 are going to be equal because the rectangles top and bottom are parallel, and this is acting as a transversal, previous chapter, and therefore angle 1 and angle 4 and angle 2 and angle 3 are alternate interior angles, and therefore they are equal. Okay, what else do we know about these shapes? Because they want us to figure out whether orange equals blue. So far I have angle 1 and 4 being equal, 2 and 3 being equal. See, these are quadrilaterals, so I need 2 more angles. Well, here's a right angle, here's a right angle, here's a right angle, here's a right angle. So the other angles are also equal. What about my sides? Could I say my sides are equal? Well, this one equals this one equals this one by virtue of the hashtags, this one equals this one, and guess what? This side is in common to both, so I just put 4 hash marks there, and by the reflexive property, JK equals JK, so therefore I can say that these two shapes are congruent because I have identified all angles being congruent and all sides being congruent. And when I say that, I mean that I'm able to pair up an angle from the orange with an angle from the blue. I can do that 4 times. I'm also able to pair up a side from the orange with a side from the blue. And that's how I show my congruency. So yes, these 2 figures would be congruent. Okay, so this example is just kind of a fun way to fill in your triangles. So if they give you some marking, so they told me that this is a red single mark and it's worth 45 degrees. If I see the same thing over here, that's also 45 degrees. Okay, so then look down here. I have a 30 degree and a 30 degree because they have the same markings. So using the third angle theorem, if I know that these 2 angles sum to 60, and I know that inside a triangle I have to have 180 degrees, then I know that this angle right here is 120. Okay, what else do I know? Well, I know this 120 angle and this other angle are a linear pair. Linear pairs sum to 180, so therefore this missing angle is a 60. Because of vertical angles, this angle over here is also a 60. Because see how it's right across the vertex from the other one? So now I have the same situation I had a second ago. I know 2 angles. I know this angle and this angle, and I can figure out this angle by doing subtraction because the 3 angles have to sum to 180. So I'll leave that exercise for you. Because these 2 angles match these 2 angles, I know that this missing angle also has to be 75. Now, after I filled in all my angles, I'm going to read this question. It says, find the measure, so when you have an M in front, it means measure, of angle BDC. So angle BDC is this big angle right here. So in order to get that whole angle you've got to add the 30 to the 75, and you get 105. All right? And then there's a couple more extra practice problems that we can go through. So this example, they give you the shapes, they give you all the markings. Your job is to write the congruency statement. So I started with the single hash mark, went to the double, went to the triple. That's how I got X, Y, Z. Then I have to start with the single, I have to go to the double, and I have to go to the triple to identify the triangle that's congruent to X, Y, Z. And it is NMP. I then get my angles equal. I know my angles are equal because that's how I set it up, but I can identify them below. X equals N, Y equals M, and Z equals P. Okay, those are all set. Then identify your segments that are equal. The first two letters, XY, equals NP. Use your segment notation above. The last two levels, so actually, I guess I switched it around. I did first and last to get XZ equals NP. And then I did second and third equals second and third to get the last ones equal. And if you look at these pairings and compare it to what you see in the figure, you will see that that's consistent. So there are more examples here. I did not do all of them in class, but I can do all of them here, and then you can pick and choose which ones you find are helpful. So they say in the diagram, ABCD is congruent to FGHI. So follow the letters and see your shapes. Based on this information, I then made markings with my sides. Okay, and then what I'm doing is figuring out what they need to know. So I have to solve for X and Y. So here's an X, GF, and GF has to equal AB. So I've set 3X minus 6 equal to 9, and then I solved for X. X is 5. So I know that so far. Okay, so then look at this angle here. This is angle K. Angle K has to equal angle D. So that's this setup. And then I went ahead and I plugged in the 5 for the X because I had two variables in here. So I got rid of the X variable by substituting in the value I solved for up here. Then when I solve for the Y, I get 12. So my answers are 5 and 12 for that. And you can stop the video, kind of work through that, make sure that makes sense to you. Okay, so then this is a rectangle right here. So as I mentioned before, rectangles, all their sides are parallel to the other side. So this is parallel to this, and this is parallel to this. They're also congruent. So it says Maggie took a piece of fabric, and the fabric is above, shown in the diagram, and cut it in the diagonal to make a scarf for her friend and herself. Are the two pieces the same size and shape? Well, they look like they are, but let's prove it to ourselves. All right, this diagonal is operating as a transversal. Therefore, angle 1 equals angle 4, and angle 2 equals angle 3. So I know that so far, I've got two angles equal to two angles in the other triangle. Here's a right angle, here's a right angle. So far I have three angles equal to three angles. Now we have to verify the sides are equal. Well, the markings tell me that this equals this, and this equals this. So the only thing that's missing is this side they have in common. Well, by the reflexive property, I can say SU equals SU, and I have found that all three angles have corresponding angles in the other triangle, and the three sides of one triangle have corresponding sides in the other triangle. Therefore, I can say without a doubt that these two pieces, these two triangles that make up this rectangular piece of fabric, are indeed congruent. Okay, so think about that for a sec. Okay, so then here's our last example, example 4. Looking ahead, they want me to find YXW. YXW is this big angle right here. So what I'm seeing is I have some things marked. I'm going to fill in the rest. So this was 40 with 2 hash marks. Then I wrote that this is 40 over here with 2 hash marks. Then what else do I have? Oh, this is 35. And so this has to be 35 because they both have the same single hash mark. And then lastly, I can figure out by the third angle theorem that 35 and 35 is 70. I need 110 more degrees to get a triangle. So this top angle is 110. Then I know that the top angle of 110 and the angle next to it have to be a linear pair. That makes this 70, and then because of vertical angles, this is 70. So I've got all kinds of angles filled in here. So if I want to find the measure of YXW, I'm going to add 35 and 70 right over here and get 105. And that completes the notes for 4.2.